Hello everyone, welcome to Drawing Hub. This is Sanjana, and in this video we'll be starting with a new series of algorithm analysis and design of semester 5 and semester 6 for KTU syllabus. We'll start with module 1, and before going into so much of technical things, let's just get into the introduction. Let's start from the basics. First of all, before learning the subject algorithm analysis and design, we need to know what algorithm is. What is algorithm? That is the first question we need to address. Before going on, as I told you, before going on to technical things, let us start this with a simple example. Suppose you need to make a cup of tea or coffee, whatever it is. What are the steps you will need to follow to make that cup of tea? That is a question. Okay, how to make tea? You don't need to think so much of things. You just need to know how to make tea. Okay, step 1. What do you do first? You need to boil water. Yes. Okay, once the boiling is done, you have to add tea leaves. Okay, that is the important part. Okay, add tea leaves. Then, what is step 3? You can add milk if you want to. That is optional. If you want a milk tea, you can add milk. Otherwise, you can just go to the next step. And what is in the next step? You can add sugar. Again, this is also optional. You can add sugar if you want to. If you want elaichi, you can add that, or you can add both if you want to. Then, what is the next step? And once all this is done, your tea is ready to be served. So serve the tea. These are the 5 steps to make tea. So these steps, following a procedure in steps, is what we call as algorithm. So this is the algorithm. Simple algorithm, a real life example. That's what we have done right now. So what you need to know is, here we have multiple inputs, right? We have water. Water is an input. Tea leaf is an input. Milk is an input. Sugar and elaichi were input. And after adding all these input, we got the final output, the tea. That is the final output. What can we understand from that? After having a finite number of inputs, we get the result. First of all, we have a problem. What was the problem we faced here? We need to make tea. In order to make tea, we required certain number of inputs. How many inputs did we have over here? Okay, how many inputs did we have over here? This is water is 1, tea leaves 2, milk 3, sugar 4, elaichi 5. 5 inputs. We had 5 inputs. And after that, after processing those inputs, we got our final result. We get the output. So keep this example in mind as we go forward so that it will be easy for you to understand what is actually being told. Try to relate it. Okay. So what algorithm is? It is actually coming in the design phase. First of all, as you can see over here, it is written in simple English format. There are no codes used there. There are no mathematical notations. Nothing is used. It's in simple English format that you can read. The user can read, and okay, you have seen a cookbook, and cookbook will be like, there will be step 1. You have to do this. Step 2. You have to do that. That step-by-step procedure is what we call algorithm. Those are the instructions that we need to follow in order to make a system, or in order to make a program, or we need to do a task. For that, what all steps we need to do. That is called algorithm. So an algorithm, it is a finite sequence of instruction. There are instructions, and what you need to remember always is that they are finite. They are finite. We cannot say there are infinite. We will, at some point, we will have to finish writing them. So there are finite sequence of instructions. And why we are using algorithm? As I told you, we need to solve a problem. In order to solve a problem, we are using algorithm, and that problem will be solved within two things. There will be a finite set of instruction, and the problem will be solved within a finite amount of time. They both are finite. So these are the two things you need to remember: finite sequence of instruction and finite amount of time. And we use algorithm before we implement a system. We need to have an idea before we just go and make the tea. We need to know this is the first step I have to do, and then I have to do this. Can I just add sugar and serve tea alone? No, without boiling the water, without adding milk, without adding tea leaves, if I just move on to step 4, then is it possible? How is it tea? Can the tea be served? No, tea will not be made over there. So I have to follow that correct sequence. So only then that order has to be maintained. Only then can I get the final output. The first thing, what is the difference between program and algorithm means? Program is something which comes in the implementation phase, whereas algorithm is something which comes in the design phase. We'll learn what system life cycle is. In that we can learn in detail. Okay. Then we have certain. So this is a basic idea of what algorithm is. Now we need to know what are the characteristics of algorithm. That is something very important. We have so many characteristics here for algorithm. First of all, what you need to know is it should be unambiguous. Unambiguous, ambiguity means something which is unclear, right? So what is unambiguous? It should not be unclear. Whatever thing it is, we should have a proper clear idea about it. That is, when we try to come to something, like if I want to get an output, I should get only, there should be one meaning for that particular algorithm. It cannot have multiple meaning. That is, if I just try to make tea, right? It should not mean that if I follow these steps, I can get coffee and I can get tea. No, if I follow those steps, I will only get tea. There is no possibility for getting coffee. That is unambiguity. Whatever thing it is, that it should be clear and it should have only one meaning for that. That is unambiguous. Second, there will be input. There will be input, there cannot be input. That is 0 or more number of inputs will be there in algorithm. 0 or more number of inputs will be there. Then third one, output. Okay, we are doing it to get an output. Okay, of course there will be one output or there can be more output. One or more output will be there. Then comes finiteness. Finiteness is, I've told you, finite amount of time is there. Yes, the algorithm must terminate at some point. It cannot keep on going. It should terminate at some point. So it is finite. It should end at some point. The next one is feasibility. Feasibility means we should be able to implement it with the available resources. Feasibility means we should be able to implement it with whatever the resources is available. We should be able to make that happen. That is feasibility. Then we have independent. Independent means algorithm, as I told you, it is a step-by-step direction process. So it cannot depend on anything. It should not depend on anything. That algorithm should be independent of itself. Whatever decision it has, it's alone. It is not depending on any other things. Then comes efficiency. Efficiency is something which is very important. Why? Because time and memory. In efficiency, how we are calculating efficiency is in terms of time and memory. So on the basis of time and memory, if the time used is less and the memory used is less, we can say that algorithm is efficient. We can say that that algorithm is efficient. So what are the steps that we need to know? The characteristics of algorithm: it should be unambiguous. there should be 0 or more input, 1 or more output. Finiteness, that is, the algorithm must terminate at some point. Feasibility, it should be feasible with whatever available resources are there. Independent, it should be independent. And efficiency, based on the time and memory. The time used and the memory used should be less. Then we can say that algorithm is efficient. Now, we have actually looked an example of T, which is the real life example. We can check something from programming side. We do not think about so much of, do not need to stress, just know what it is. We'll look a simple example of program to add two numbers. To add two numbers. That is a simple example, right? First, we'll try doing with this. Okay, so what is our problem? First, identify the problem. This is our problem. I need to get a program to add two numbers. Yes, that is my problem. And what do I do? What do I do? I need to write step by step. Okay, so I have to always write step 1. I'm starting my algorithm. Yes, this is very important. Step 1 will always be start. Because I have to tell, okay, I'm starting the algorithm. And the last step will always be stop. You know these things. You have already learned that in data structure. Okay, step 2. What is step 2? Our problem is to add two numbers. For that, we need the input. We need the user to enter two numbers. So, enter two numbers. Once you have entered the two numbers, now the operation can be made. So, step 3 is sum of numbers. Now, the sum of the numbers will be taken and then we want that to be printed. So, I can say display the sum or print the sum. Okay. Now, I got the output. So, we do not know if the algorithm is over or not yet. So, what we have to do as step 5, that is, I have to inform, okay, my algorithm is over. So, stop. These are the 5 steps in order to write the program for adding two numbers. So, we know what our problem is. What are the inputs over here? What are the inputs entering the two numbers? These two numbers, 1 and 2. Those two numbers are the input. And what is the result? I have said print the sum. That is, this is the output. That is the basic thing you need to know. Now, if we are trying to do something from architectural way or in a diagrammatic way, if you want me to say, I can do that also for you. We have a computer or we have a system. We will give input, and we are expecting output. For that, we will have a problem. Okay, there will be a problem, and how that problem is resolved, I will write the algorithm or make the algorithm and give it to the computer. Okay, and then I get the output. So, this is step-by-step procedure for problem solving. Now, we have to learn certain terms which we can do in the next video. So, till then, bye-bye.